Hello everyone, this talk is about dual teacher class incremental learning with data-free generative replay. I'm Yoojin Choi from Samsung, and this is a joint work with Mostafa and Jungwon. The goal of class incremental learning is to learn a unified classifier that can recognize all classes learned so far when training data for unseen classes arrive incrementally. The major challenge of incremental learning is catastrophic forgetting, which is caused by overfitting to the new data when the past data are not available and cannot be used during the incremental training. Generative replay or distillation-based regularization method have been proposed to mitigate catastrophic forgetting. Our contribution in this paper is twofold. First, we introduce data-free generative replay to curtail the extra burden of storing any past data or pre-trained generative models for old classes. DFGR can also be used to augment data for new classes if not enough data are accessible for them. Second, we propose dual teacher information distillation to transfer knowledge from two teachers to one student. This figure shows the timeline of our proposed dual teacher class incremental learning with data-free generative replay. Note that generative models are trained from scratch without any data by the current model trainer who want to adapt the model for new classes, so no extra memory is needed for pre-trained generative models or past data. In data-free generative replay, we minimize cross-entropy loss and batch-norm statistics loss. The CE loss is used to verify the labels of generative samples by using the pre-trained teacher. The BNS loss is used to confirm that the generated output is similar to the original training data at the batch-norm layers of the teacher. In this slide, we show some example synthetic images from data-free generative replay, given a pre-trained ResNet 18 model for ImageNet dataset. Observe that using both CE and BNS losses produced good labeled synthetic samples. Information distillation transfers knowledge from a teacher to a student by maximizing the mutual information at their intermediate layers. We altered the original information distillation method to transfer knowledge from two teachers to one student. In incremental learning, we use the model trained for new data as the second teacher. Finally, our proposed dual teacher class incremental learning scheme deploys both dual teacher information distillation and data-free generative replay, as shown in the figure. The synthetic samples from data-free generative replay are used in information distillation as well as data-free KD. For experiment, we implemented our proposed method on top of LUCIR, which is introduced by Howe in CBPR 2019. We evaluated our scheme on three datasets, CIFA 100, ImageNet subset, and ImageNet full. As you can see in the plot, we observed consistent gains from our proposed method over the baseline in all three datasets. We performed the evaluation study for DFGR and DTID. We observed that both schemes improved the performance as shown in the table. We performed additional experiments for different numbers of base classes and different numbers of incremental classes. In all cases, our proposed method improved the performance over the baseline method. We finally investigated data-limited class incremental learning, where we can access only a few samples for new classes, for example, due to data privacy. In this scenario, we employed dual data-free generative replay, one for old classes and another one for new classes. Our proposed dual teacher scheme showed promising results in this data-limited scenario of class incremental learning. In conclusion, we proposed a novel dual teacher knowledge transfer method for class incremental learning, which deploys data-free generative replay and dual teacher information distillation. We implemented the proposed schemes on top of one of the state-of-the-art class incremental learning methods and showed their gains in various settings. We also demonstrated the potential of DFGR for data-limited class incremental learning. Thank you for listening.